So I still won't say my age, but at least, right, I would mention that I graduated from NTU with a Bachelor of Aerospace Engineering. So for those of you guys who want to go into aerospace engineering, you can talk to me about it. I can share my experience. For the girls who want to go into engineering school, I can also share my experience with you guys. Let me just tell you, if you go into engineering school as a girl, right, you're basically treated like a queen. Yeah, there's very little girls, way too many boys to want to impress the girls. Yeah, that was the expression as well. I woke up one morning, I go to school, I look at all the boys, I was like, oh my God. It's something I have to face for the rest of my 4 years there. But anyways, I graduated with aerospace engineering. Then I went back to NIE and did my master's in education. So I did both the science side as well as the art side. So if you guys have any questions with regards to these two sides, you can ask me as well. And then it's completely two different arenas, okay, I would say. Okay, so our flagship centers, you guys are in one of the flagship center that we have here, basically Bukit Timah, Marine Parade, and Serangoon. Flagship meaning to say that we kind of own this space, so it's really like our center. But if let's say next time you guys want to come for classes, you can come for any of these. But that being said, if you don't stay near there, we also have other spaces that we co-share with other people. So like Toa Payoh, Serangoon, Jurong East, as well as Woodlands, that you guys can go and explore. Okay. But the fun thing about our center is that we don't just have a tuition center, we have study lounges as well. So if you want to go and study and you attend classes, you just got to ask your teacher the PIN code so you can just come in and study. Rather than you all go for cafe and then spend like $8, $9, $10 on a coffee, right? We have plug, we have aircon, we have Wi-Fi, and we have snacks. Not here, but in other of the centers, you have snacks, then you can just go there and study, not go there and chill. There's a difference, okay? Okay, now, brief introduction about me. So I've been teaching from 12 years. Basically, I've been teaching since I was studying as a means to earn income. Then after that, I realized that, okay, maybe I should do this for a living, and then has never stopped teaching ever since. So I basically taught for like 12 years. Okay, so yeah, 3 things about me you should know. Number 1, it's very important, I'm a Taylor Swift fan. So for those who needs me, actually no need really lah, but my students, right, we have this like session that we sit down and really go and buy tickets together, try to get tickets. Then secondly, I'm also a Formula 1 fan. So for those of you guys going to F1 next week, yeah, I'll see you guys there, and I'll see my if you all know who LH is, you all will understand. Lewis Hamilton. Yeah. I dreamt that he hugged me, but anyways. Okay. Then I'm also a food lover and a travel lover. So you often find me traveling at the end of the year, because my way of working is I work the entire year hard and then tell myself, say, okay, I need a break off, then I'll be out of Singapore for like 1 month. You won't see me there. Okay, so these are the 2 things that I like. So if you like to eat food, please recommend me as well, but no cafe food. I don't believe in cafe food. I think it's something that I can do myself at home. But if let's say hello, okay. So yeah, as I was saying, I don't believe in cafe food, but I believe in the dodgier the place, the better. Especially you eat, then halfway you see a rat run across. Yeah, that means the food is good. Okay, so just call me up to those kind of places. Okay. So hopefully you guys can benefit from today's session. Learn as much as you can, and then try to use whatever you learn and try to remember whatever you can remember today, especially in your exam. The main thing I want you guys to take note of is, right, chemistry is never about memorizing. Colors wise, all these things you have to memorize, that one no choice. My advice is just memorize 24 hours before the exam. That one, your retention will just maintain 24 hours. Then after the exam, you can throw it away. But I would rather you guys understand what is going on first, then you start memorizing. That will help your memorizing so much more better. Understand? So spend the bulk of your entire academic year trying to understand what is going on. Then leave the memorizing to the part. Don't rush to memorize without understanding, because like that, right, you will not be able to answer questions. Okay. Is it very warm? You want me to turn up the aircon? Is it very warm? No? Oh, okay. Okay, so what I'll be doing today, number 1, based on experience for the past 2 sessions that I did at Marine Parade and Bukit Timah, they wanted us to do more questions, less content. I'm not sure about you guys, but maybe I'll try that today. We do more questions, slightly lesser content. I'll not say less content, because content you guys can learn it from your recorded lecture, from your school, or from your notes, okay? But we will still do questions understanding the content, and we'll work on some of the misconceptions that you have. So if you guys have anything that you need to ask, you can ask me now. You want to ask me privately later after the class is fine as well. Just make sure that anything you don't understand, you ask me, understand? And anything that you think you know is all wrong, trust me. Whatever student thinks, oh, I know already, but then when they say out the answer is completely different, so that means they don't know. So just try to answer or respond me if you can. Understand? Can? Then we'll look at answering techniques as well. Basically, what are some of the keywords that the questions is looking for, or usually the answer key ones. So I have some students, my student who came and tell me, say that chemistry was actually a very easy topic to score as compared to physics, because they feel that chemistry is very repetitive. The questions that they ask is always the same. The answer that they want is always the same kind. The only thing that changes is the context or the content of the question and the answer. I didn't believe it at first, because I thought like chemistry is, how can it be the same type of questions that they are testing all the time? But when I went back to look at all the question papers, right, I realized that it's actually quite true. All your chemistry questions, right, is always the same kind of questions that they test, the same type of content that they test. The only thing that changes really is just the content. So which means if you do enough practices by right, you should be able to get an A. Yeah, 1 day 5, 365 days times 5, that's 15,000 questions that you can do. Easy, right? Then you apply it to times 4 subjects. Yeah. 1 day you can do how many questions really? But that's just saying. Okay. So anyways, let's just begin the session today. Now, hopefully you guys can benefit. First things first, can we for every of my lessons, right, the actual lesson, I took this today to be an actual lesson. You'll be receiving a revision summary of the content that you'll be going through. So an actual lesson with me will be something like that. You'll get a revision worksheet, because honestly, right, I think your school notes has a lot of content that is sometimes not necessary for you to know. And then what happens is that you end up having to flip through the entire paper. So for me to create that revision kit is mainly just for you to, before you go to school, when you have an exam, the day before the exam or something like that, and you need something quick to remember, then that's where you have a revision kit. Understand? Okay. So it could either be in the form of a summary. Sometimes I'll do it in a form of summary, or sometimes like physics, I will do it in a form of concept map. So it's either one of these that you get in class. Okay? Okay, this is the one for physics. So yeah. Okay, but anyway, let's take a look at these. Then there's also some question banks that I received, given you guys. So if you guys don't receive any of those, please let me know. I'll hand to you guys. Those online can also download the summary as well as the questions from the Google Drive. Okay. Now, let's start off with the revision for chem energetics. I'm not going to go through all the definitions for chem energetics. The only thing that I want you guys to take note of is, first things first, when we look at chem energetics, right, the entire topic, if you look at the bigger picture, you realize is revolving around finding this thing called your delta G. Okay? Delta G is also known as the Gibbs free energy, which in the end of the day tells you whether or not a reaction is spontaneous or not. Now, what's a spontaneous reaction? It's a reaction that will happen without any external energy involved or any external help. An example of spontaneous reaction is like melting of an ice. So imagine if I put the ice on the table, okay, and I leave it alone. I don't give it any external help, any external energy. The ice will naturally melt by itself, right? So we call that a spontaneous reaction. So as a chemist, you want most of a reaction to be spontaneous. Why? Because efficiency, I don't have to bother with the equation. I just got to put the right raw material in, everything will happen by itself. But in order for me to have a spontaneous reaction, I will need to calculate that. And in that case here, delta G is what I'm looking for. Okay, so in your exam, if you see questions, will this reaction be spontaneous? Will this reaction be feasible? Usually, they are looking for your delta G. Then you extend. Okay, what is delta G? Delta G, as per what the formula gives, is delta H minus T delta S. So delta H, as what you learn, is known as your enthalpy change. And it forms the bulk of this entire topic. Basically, you are finding the amount of energy changed involved inside a chemical reaction. Okay? Then minus temperature T delta S. Delta S is known as your entropy. So as a chemist, you want to find out how much energy is involved inside a chemical equation and how disordered my chemical equation is. Together with these two, I'm able to determine if my reaction is spontaneous or not. Understand? Okay, so the bulk of this entire topic is hence to find delta H, and delta H is therefore given as all of these different definitions: reaction, formation, so on and so forth. There is a lot of them that you need to remember. Okay, now I'm not going to go through these because I think this is the easier part for you guys. You guys can go up and feel. But what I want to mention about this enthalpy change is, number one, most of you guys will know what this symbol already means, correct? In enthalpy change in energetics, it means standard state. However, a lot of you guys confused between standard state and standard temperature pressure. Is what all my J2s cannot answer because they thought it was the same thing. So I need you guys to understand, standard state is actually at 25 degrees Celsius, 298 K. But standard temperature pressure is actually 0 degrees Celsius, 273 Kelvin. That's the difference. Understand? When do you see STP? In mole concept. As such, the volume in STP that you use should be 22.7 dm cubed. But for standard state, it still remains at 24.0 dm cubed. Understand? Okay. In addition, standard state is taken to be 1 bar. STP is also taken to be 1 bar. Now, 1 bar and 1 ATM is completely two different things. 1 bar is times 10 to the power of 5. But 1 ATM is 1.01 times 10 to the power of 5. There is a discrepancy of 0.01 times 10 to the power of 5 Pascal, which is still quite a lot of pressure. So I've seen a question before that actually tests students on why is there a difference in some energetic values, purely because the pressure measure was different. Understand? Okay, so just take note whether the question is asking you at standard temperature or standard state. These are the two different things. But for your energetics, we are all looking at standard state, so at 298 K and 1 bar. So for all the different values that you have here, or all the different definition, the main problem that students face is, how do I memorize the definition? It's way too many words and way too many things. So my advice to you is always remember, whenever I want to define enthalpy change, I will always start off with an enthalpy change of something. Now, enthalpy change means heat change. So if you are very sure that the reaction is an exothermic reaction, then you say the heat change, you changed it to heat released. If you are very sure that the reaction is an endothermic reaction, then you use heat adsorbed. Understand? So the definition you memorize this, the heat changed involved when. Then the next part of the definition to remember is what is the 1 mole that they are referring to. Can you see that? So different definitions will all have different sets of 1 mole. Clear? Okay. If you guys can't finish copying, it's fine. I'll upload this into the G drive, then you'll just download and copy from me. Clear? Okay. But my advice is, remember now, what is the 1 mole that they are talking about? So now your definition extends to what? The amount of heat change involved when 1 mole of something is followed by description of whatever they are looking at. What is the description for reaction? Molar quantities of reactant react. What's the descriptions of formation? Forming your product from constituent element. What's the description of combustion? Completely burnt in excess oxygen. Do you understand? Then at the end of the day, all definition will follow by standard state at 298K and 1 bar. Okay, clear? These are the different values for enthalpy change. Now, there is just a few that I just want to go through with you guys. First things first, number 1 would be standard enthalpy change of neutralization. So I'm just going to pick a few special ones to mention. Okay. For enthalpy change of neutralization, we're going to talk about these. Why? Because number 1, when you think about neutralization, what will you think about? Acids and bases. So therefore, enthalpy change of neutralization is defined as the heat evolved or heat released. How do I know that it's exothermic? If you did the experiment before, titration, especially in Set 4, remember you drew a graph that has a cross like that? Yeah, so you know for sure that neutralization has an increase in temperature. So heat is released, hence heat evolved. Then when Now, for neutralization, the unique thing is the 1 mole they refer to is not for acid, not for base, but the one for water. So write your chemical equation such that you keep water to be fixed at 1 mole. The rest all balance according to that water. Understand? So when 1 mole of your water is formed from an acid and bases neutralization reaction at 298K and 1 bar. Clear? Okay. But why do I want to talk about this? Because next time when you guys learn acids and base equilibrium, which is not now, you all started already or finished already, then you should know acids and bases are what? They can be categorized into strong and weak. Am I right? Now, standard enthalpy change of neutralization will be a fixed value at negative 57.0 kilojoules per mole if you use strong acids and strong base. So any strong acid, strong base reaction will give you a fixed value at negative 57.0 kilojoules per mole for your enthalpy change of neutralization. Understand? However, if let's say one of the acid is strong and one of the base is weak, or either one is weak, then your enthalpy change of neutralization becomes less exothermic, meaning to say it becomes less negative. Understand? Okay. Now, what's the reason? Why is it that now lesser heat is being released? Because having a weak substance means the substance will partially dissociate. So some of the energy that was released is now taken back by the weak substance to further dissociate so that the reaction can proceed. Do you understand? Okay, so I repeat, if you have something that is weak, whether is it bases or acid, your enthalpy change of neutralization will be less negative because some of the energy that was released is now taken back by the weak substance to further dissociate into ions. Okay? So that's one that we look at, enthalpy change of neutralization. Okay, the next one that I want to look at is this thing here called enthalpy change of hydration and enthalpy change of solution, because I think a lot of students tend to confuse between these two. Now, when we take a look at enthalpy change of hydration, it does not mean the same as enthalpy change of solution. When we take a look at enthalpy change of hydration, it is dissolving 1 mole of gaseous ions into infinite volume of water. Meaning to say, I am literally making my gaseous ions into the aqueous form, or just making them wet, basically. Okay? So that is enthalpy change of hydration. Now, enthalpy change of hydration will always be exothermic, meaning heat will always be released. What's the reason? It's because you are forming bond. The moment you add water to ions, you are forming a bond. The question is, what bond are we forming? Hydrogen bond? Did someone say that? Ions with water molecule. What bonds are we forming? Ion dipole interactions. Understand? So the moment I dissolve in water, I form ion dipole interactions. And since it's bond forming, it will always be exothermic. Okay? So you see ions like ionic bond. As such, what is the enthalpy change of hydration dependent on? Enthalpy change of hydration is therefore dependent on this thing called your charge density. Which means to say, the higher the charge of your ion, the more energy you will release during the bond forming process. The smaller the radius, the more energy you will release. It's just like what? Ionic bond lattice energy. Lattice energy is directly proportional to charge density, right? Okay, clear? So the next one, enthalpy change of solution. Now, then what is enthalpy change of solution? If hydration is to hydrate my ions, solution is to completely dissolve my ionic compound. So that's the difference. When I talk about enthalpy change of solution, I am really dissolving 1 mole of my solute in an infinite volume of solvent. So chemical equation wise, this is how it looks like. If I have sodium chloride solid dissolving into its ionic aqueous form, then that is enthalpy change of solution. Okay? But what's the relationship then? If you think about it, in order to dissolve my ionic compound, step by step wise, what do? I would first break down my ionic compound, right? Breaking down of an ionic compound would be lattice energy. But the definition for lattice energy is ions form compound, not compound forms ion. So if I'm going to do compounds form ion, I have to add the negative sign in front because I'm flipping the direction of the arrow. Clear? So after I have broken them down into ions, what happens? I'm going to hydrate them because now it's ions turning into the aqueous form. So according to Hess's law, what do you see? You realize the enthalpy change of solution is the summation of my lattice energy and enthalpy change of hydration. Okay, so now understand the difference between solution and hydration. Clear? Can? Okay, so moving on, let's take a look at the next one. Bond dissociation versus bond energy. There is also a difference between these two. A lot of you guys are very used to bond energy because that's what they usually test you on. But there's a difference between bond dissociation energy and bond energy. Bond dissociation energy is the amount of energy to break a specific covalent bond in a compound. For example, if this is methane, when I break a CH bond from my methane molecule, that would be bond dissociation energy. Okay? And since it's bond breaking, it is therefore endothermic because I need to take in heat to break a bond. Okay? But bond energy is not bond dissociation energy. Bond energy is the average amount of energy needed to break a covalent bond into its gaseous state. Meaning to say, I only have a covalent bond here, like a Cl-Cl bond. I'm going to break this Cl-Cl bond. That's my bond energy. Now, the thing about bond energy is, it is an average energy value. Why? Because the ones given in your data booklet is an average of all the different experiments that have been done by scientists. They found an average value, and that was the average value in the data booklet. Okay, probably rounded up as well. So when they have a question where they say somebody did an experiment or you did an experiment to calculate the bond energy of, let's say, Cl-Cl, then they ask, why is there a discrepancy between your value and the data booklet value? You have to understand that the data booklet value is an average of millions of scientists' experiment, but your experiment is individual. So that's why that's a difference. Understand? Not everything attribute to heat loss to surroundings. Okay, Ken? Okay, so those are the two that I want to talk about. Then the rest are pretty straightforward. IE, EA, lattice energy. So those I don't have to talk about. You guys can just copy those next time when you download the answer key from the drive. Now, so we have went through all of that. The next thing I want to talk about is therefore this one here. How do we answer chem energetic questions? So chem energetic questions, right, is very straightforward. It's like chem kinetics for those who have already done chem kinetics. And there's always this set of questions that they can ask you on. So in order for you to calculate at the end of the day, our problem solving approach, right, revolves around finding this thing here. Because why? Remember, at the end of the day, I want to find delta G. Delta G, one of the components is delta H. So my entire problem solving technique, right, revolves around finding delta H. How do I do that? I've categorized them into, I think, 5 parts. The first part using shortcuts. So always read the question. Not all the time you need to draw energy cycle, energy level. Don't straight away see, oh, energetic, I need to draw a cycle. No, energetic, I need to draw a level. No, read the question. If the question only gave you formation values, and specifically only formation, you can straight away make use of a formula to find the enthalpy change of reaction. So if they gave you formation values, you can then say the enthalpy change of the reaction is the formation of all the products minus the formation values of all the reactants. Understand? In short, we memorized it as FPR, CPR, but the other way around, FPR. Okay? That's only if they give you formation. But take note, enthalpy change of formation for elements will always be 0. So if they don't give you the formation values of a particular substance, you check, is it an element? Is that why they don't give it to you? It's because it is 0. Understand? Now, what does element means? Elements is not the same thing as atom. Elements means anything that you can find in the periodic table, like sodium, magnesium, oxygen gas, chlorine gas. These are all considered to be elements. Understand? Okay. Now, what happens if they give you combustion values? If they give you combustion values, then I would use, to find enthalpy change of reaction, the combustion value of all the reactants minus away the products. So it's the opposite of formation. So just take note for that. Okay? So that's the second shortcut that you can use to calculate enthalpy change of reaction. Now, the third one would be bond energy. So for bond energy value, this one is something that you've learned before in Sec 4. To find the enthalpy change of a reaction, I will take the bond energy required to break bonds minus the bond energy required to form bonds. Some of you guys might remember it as reactants minus product is the same, because you break all your reactants, you form all your products. Understand? But my advice to you guys is this: draw all the full structural formula of the species in a chemical reaction. Because some of you guys like to not draw all, then you go and see what is broken, what is formed, then go and use the one that is broken and formed to figure it out and then cancel. It's very confusing. I'd rather you guys break all, form all. Why? Because now in JC, right, the structure is not so simple. Like organic chem, you're very used to drawing OH, but you need to understand that OH is also made up of an O-H bond. So a lot of people tend to forget about this. So just make sure you draw all the bond, break all the bonds. Understand? Okay. So these are the 3 shortcuts that we can use to find enthalpy change of reaction. So far, any question? No? Okay, now let's move on to the next one. Another type of question that can come out in the exam is they throw you an experiment. They say they did an experiment in a bomb calorimeter in a laboratory. Find the enthalpy change of reaction. Now, first things first, this type of question requires 2 formulas. The first one, Q equals to MC delta theta. For those who do physics, this equation is probably very familiar to you guys. But for those who don't, what is actually Q? Q is basically the heat that is involved inside the reaction. Meaning you do your experiment, how much heat was released or how much heat was absorbed, that's your Q for the experiment. Okay? You can calculate it by taking number 1, the mass. But for this particular mass, take note, in your chemistry syllabus, we only take the mass of the solution. Okay? In your experiment, you can do a lot of things. You can make solution, you can add solid into solution, stir, dissolve, whatnot. But for this mass here, we only use the mass of the solution. Understand? If the question threw you the mass of a solid, you do not put it in. Clear? Okay. Next, C here is what we call the specific heat capacity. So usually it's given as a fixed value of 4.18 or 4.2 for some questions. Understand? It is basically the amount of heat that is absorbed or released or required to change your substance of 1 gram by 1 degree Celsius. And delta T here is your temperature change. Now, do I need to add 273 for my temperature change? No need. Temperature change, degree Celsius, Kelvin is the same. So first things first, I find my Q. Now, once I'm done with Q, the next thing, to find the enthalpy change of the reaction, I will take Q divided by the number of moles of my limiting reagent. Okay? But before I do that, I need to ask myself, is my Q plus or minus? This sign you have to include yourself. Okay, how do I know whether it's plus or minus? You look at the question. If the question says the temperature rise, means heat was released. So therefore, it is an exothermic reaction. Your Q would be negative. But if the question said that you did the experiment and there was a temperature drop, then this would be an endothermic reaction. Then your Q would be positive. So once you have determined the sign, you put it in. Now, what is the limiting reagent that you put in? Remember when we did the definition, I told you to take note of the 1 mole of something being formed. That's when you have to include the moles for that substance here. But nice enough, I mean, just nice, your entire syllabus for experimental only revolves around neutralization or combustion. So if it's a neutralization reaction, then you divide by the number of moles of water. Understand? If it's a combustion reaction, you divide by the number of moles of fuel. Clear? Okay, so this is the 2 formula you use if you have experimental data. Any question? Okay, now the next thing, once you're done, we take a look at the 3rd way to calculate your delta H. The 3rd way to calculate delta H would be obviously your energy cycle. Now, a lot of students tend to call this cycle Hess law. Take note, this cycle is not Hess law. This is not Hess law. It's just an energy cycle. Hess law is the law that states that for a fixed start and a fixed end, my start to end path will be the sum of all the individual paths added up together. Okay, so we'll look at some questions later to learn how to draw energy cycle. Why I say so is because some of the students still don't know what to write here. I know you guys all know what to write here, but then when it comes to this part here, you just blank out, don't know what to do. Okay, so we'll look at some questions later to draw energy cycle. So the next one, the next part to actually solve for delta HR would be energy level. So take note, if the question asks you to draw energy level, it is different from asking you to draw energy cycle. Energy cycle is a cycle. Energy level, you have a y-axis, and then you have all the different levels. Understand? Okay. So for energy cycle, we usually use these to find for lattice energy, which means ionic compound. So therefore, for an energy cycle diagram, I'm not saying that all energy cycle will look like this, but the general outline for energy cycle will be like this. Number 1, I will start off with my metals and non-metals at their standard state. So at standard state, metal will exist as something, non-metal will exist as something. Okay? Then the next arrow we draw would be, can you change the sign for this arrow? It's drawn wrongly. It's going downwards. So my metals and my non-metals at their standard state will be able to form ionic compounds in their solid state. This is enthalpy change of formation. Okay. Now, for my metals, the next step it becomes would be to form metal gaseous atom. How do my metal form its gaseous atom? Atomization. Okay. How do my non-metal forms their gaseous atom? Bond energy. So I'm going to break all of them to form their atoms. Because after forming atoms, I want to form their ions. Can you see that? So for metal to form back an ion, cation, it will be ionization energy. For non-metals to become an ion, it will be electron affinity. Then once they are their gaseous state, they will then do lattice energy to form the ionic compound. So according to Hess's law, you realize that the delta HF is equals to the sum of all of these energy added up together. Understand? Okay. Okay, so that's the 4th way to help us to find our delta H. Any question? So all these 4 different ways helps you to find delta H. So let's take a look at some of the questions here now. Can you take out your worksheet on energetics? Now, and turn to page 6, question 8. I gave you guys maybe a while to try this question out first and see whether you guys are able to get the answer. Then I will go through with you guys the answer. But I need you guys to, for this particular question, not all the energies given is required to be used. Understand? Okay? No database. Google database. Okay, I give you guys a while to try, yeah. But I repeat, not all the NLP is required because there's a part B, part C to this question. Okay. Could be back. Could be back class. I go through in another 3 more minutes. Okay, now let me go through this question. Hopefully it's not that hard, but let me show you guys a way on how to derive what I'm going to draw at the bottom of your energy cycle, since the question asks you to draw an labeled energy cycle. Okay, the first thing you have to do is, if you read the question, this is the equation for atomization of nitroglycerin. And the question says, find the extended enthalpy change of atomization of nitroglycerin, which means they want the enthalpy change from this reaction. So the first thing we always do in drawing an energy cycle is always write down the equation that I want to find out for. Okay, but take note, in energetics, all your state symbols have to be written down because any change in state will always warrant an energy change. So just write the equation as per what it is: gas plus 5 hydrogen gas plus 3 nitrogen gas plus 9 oxygen. So this is what I want to find out, delta H atomization. Okay. Then the next thing I need to do is I need to figure out what am I going to write here. So in order for me to do that, all of my equations, all the formulas that are given here, write down all the chemical equation. So first things first, standard enthalpy change of formation of nitroglycerin. If you had remembered the definition, it is when 1 mole of your product is being formed. Am I right? So that means I'm going to keep my nitroglycerin fixed at 1 mole. And form from what? Form from its constituent elements. So therefore, I ask myself, element sulfur, element hydrogen gas, element nitrogen gas, as well as element oxygen gas. All these are the elements that are required to form 1 mole of nitroglycerin at their standard state. Then you balance the equation based on this as 1 mole. So 3 of these, 5/2 of my hydrogen. What else? 3/2 of my nitrogen. And for oxygen, I have 9/2 of it. Okay, so this value is tagged to this equation. Understand? Second, standard enthalpy change of atomization. What is the definition for atomization? The amount of energy required to change either an element or a compound into its gaseous atom. So carbon solid to carbon gaseous, this value is tagged to 1 mole of my carbon. Understand? The second one, standard enthalpy change of formation of H2O. Same thing. Formation is the amount of energy required to form 1 mole of the product. Take note, this is water at the gaseous state. So don't write your equation wrongly. Understand? But from where? From 1 mole of its from its constituent elements. So elements would be hydrogen gas and oxygen gas. Okay. However, my oxygen will have to times half because there's only 1 oxygen here. So this value is tagged to 1 mole of water. Actually, 1 mole of water vapor. The last one, formation of carbon dioxide. So carbon solid plus oxygen gas forms carbon dioxide, CO2 gas. So this energy is tagged to this one here. Okay. So once I've written all of my energies, all of my equation, then to answer this question, what do I write here? I'll use what I call the cancelling method. So for me, what I do is this. I will see, this is what I have here. So in my equation, I'm going to cancel this. I'm not going to write this anymore. Next, what else can I cancel? Carbon gaseous state. I can cancel carbon gaseous state. Now, can I cancel H and O? No, because I don't have any of them here. So you realize these 2 equations are not relevant. Like I said from the start, not all I used. I only have these 2. And what is left behind? Carbon solid, hydrogen gas, nitrogen gas, oxygen gas. So that's what I write here. I'm left with carbon solid, hydrogen gas, nitrogen gas, and oxygen gas. Do you understand? Okay, so this is what I do. I write out all the equations. I'll cancel the ones that I already have. Whatever is remaining, I put it down at the center. Okay, then I'll find a way to link everything else together. So the next thing I need to do is link. So my arrow will be drawn down here. Then you realize, isn't this forming this equation? Right? But the opposite. So I just got to balance. 5/2, 3/2, 9/2. So it's the exact same equation, just flipped. So therefore, this is my enthalpy change of formation plus 364. Okay? Then the next one, I try to link up now. Carbon to solid, gaseous carbon. Then you realize, isn't there a equation here? But this value is tagged to what? 1 mole of carbon. But I have 3 moles of carbon. So my delta H1 here will be 3 times of positive 715. Understand? Okay. Then the next one. What happens if for this one here? Now, unfortunately, they didn't give us any values for this. But they said use values from the data booklet. What does this look like to you? I have hydrogen molecule forming hydrogen atom. Which particular values do we use? Anyone? Bond energy, correct. So for this one here will be my bond energy of my hydrogen, but don't forget your bond energy is tagged to 1 mole of hydrogen bond. This is 5/2 moles. So therefore 5/2 plus 436. Okay. The next one, nitrogen, same thing. Bond energy for nitrogen 2, this would be 3/2 times 944. And then lastly, oxygen, bond energy for oxygen, this would be Be3, 9/2, 496. So can you all see the relationship now? In order for me to find my enthalpy change of atomization, according to Hess law, it is the sum of these, plus this, plus this, plus this, and plus this. Can you see that? Okay, so then that's where we quote by Hess's law, the enthalpy change of atomization is equals to delta HF plus delta H1 plus bond energy 1, bond energy 2, and bond energy 3. So therefore, to find enthalpy change of atomization, I just got to add up all of them. This gives me plus 7. kilojoules per mole. Do you guys understand? Okay, clear? Was it hard? From the sound of it, yes. Okay, so this is what we call energy cycle. Remember, cancelling method works almost all the time. Understand? Okay? But in order for you to do that, you must write your equations properly. And in order for you to write your equations properly, you must know your definitions well. Because your definitions you don't know well, you don't know what is your 1 mole, everything screw up. Then all your equations would be wrong already. Understand? Okay? Okay. Once you guys are done, those done, can we take a look at question 10? Give you guys a while to try question 10. Okay, I go through in about 2 more minutes. Okay, now let's take a look at this one. Hopefully it wasn't difficult, but I think most of you guys will stumble about the neutralization part. So for this one here, they say calcium reacted with water to form aqueous calcium hydroxide. They gave the reaction as such, and they said that by using the data in the question and relevant data in the data booklet, draw an energy level diagram. So you can't draw a cycle, make sure you draw your energy axis and then all the different levels of equation to determine delta H. So first things first, what we need to do is write the equation for all the information that was given. The first one, enthalpy change of atomization of calcium. This would mean I have calcium as a solid state changing to calcium in the gaseous state. Okay, this energy is for this equation. Second, enthalpy change of neutralization. Now, how do we write an equation for this? I know you guys know that neutralization is between acids and bases. However, they did not give you any acids and base for this. So to write an equation for this, we use the ionic equation of neutralization. And do you all still remember? for neutralization, what's the ionic equation? H plus aqueous plus OH minus aqueous gives you H2O liquid. So this is one equation I can write for this enthalpy change. The second one, enthalpy change of hydration. So if you already knew, hydration is for ionic compound, changing any state of my ionic compound into the aqueous state. So this would be the enthalpy change of hydration for calcium 2+. And lastly, enthalpy change for changing 2 of my H plus aqueous to H2 gas. So I don't have the right equation for that. They really gave that to me. Okay. So what do I do now? My very first step, I need to draw an energy level diagram. So I'm going to draw my axes. Here would be energy. Okay. Now, for every energy level diagram, there will always be a start. And the start, we always deal with either elements or substances at their standard state. In that case here, we're going to draw my start here. And for my start, it will be calcium reacting with water. Can you guys see that? Okay. So I will have CaS plus 2H2O liquid. Understand? Then what I want is my CaS forming plus 2H2O forming whatever is here. Ca2 plus aqueous plus 2OH minus aqueous plus hydrogen gas. Okay, so arrow down, this is what I want to find, delta H, question mark. So let's begin our journey throughout. What is going to happen? Now, if you realize at the start, my calcium exists as a solid atom. At the end, my calcium exists as a Ca2+. So what is going on here? My calcium from solid atom became an ion. Now, all atoms, in order for it to become an ion, it will first need to turn into gaseous state. Okay, so I'm going to change my calcium into its gaseous state first. My water is just going to stick as liquid water molecule. Can somebody tell me from calcium changing into calcium solid to gaseous, what would this be? Enthalpy change of atomization. So therefore, this is delta HATOM standard plus 178. Then now I've changed it into gaseous atom. The next thing I want to change it into would be my ion. But my ion will still be in the gaseous state. So plus 2H2O. Then the question is, what energy is this? Changing from gaseous atom to gaseous ion. This would be changing from metal atom to metal ion. What would that be? Ionization energy. But you'll realize it's Ca2+, means first IE and second IE. So you go to your data booklet and add up all the IEs together, 590 plus 1150. Okay, positive 1740. So it looks as if like my enthalpy change of my calcium is pretty much done, except that now it's still in the gaseous state. It's fine. The next thing we're going to do is my water. Do you realize that water will be OH minus and H2? So what do I need to do to my water? You will need to split it up. So instead of just remaining it as water, I can split up into H plus and OH minus. Can you guys see that? And what reaction is this? That would be enthalpy change of neutralization, but the opposite direction. Okay, so if this value is negative 58, then my enthalpy change of neutralization for this one here would be 2 times of negative 58. But take note, for this one here, it's H plus and OH minus forming H2O. For this one here is H2O forming H plus and OH minus. So since you reverse the arrow, you will need to reverse the sign. So 2 times positive 58. Okay? Then you realize something, you are very close to becoming this. However, you realize that I still need to change G into AQ. So how do I change G into AQ? This would be enthalpy change of hydration of calcium. You realize it's a pretty big drop because the value is negative 1000 hydration, negative 1577 kilojoules. So end up I have Ca2 plus aqueous plus 2OH minus aqueous plus 2H plus aqueous. Okay. Then lastly, I have this, now this. Do you realize 2H plus change to H2 is the very last equation here. So an arrow down, this would be enthalpy change H1 minus 796. I don't have to times anything because it's for what the equation is mentioned. So this is how I get my energy level diagram. Okay, do it step by step, don't rush. Clear? If you can't change two at one time, then do it step by step. So according to Hess law, same thing, start to end will be equivalent to the start moving over to the end. Okay, so then we will say by Hess's law, delta H of the reaction is delta H atomization plus delta plus IE plus enthalpy change of neutralization plus enthalpy change of hydration plus delta H1. So end up, you will get a value of negative 339 kilojoules per mole. Can clear? Anyone manage to get this? The rest? Cannot. Okay, good. So this is done. Now, I want you guys to take a look at the last question for this one here, question 9. Give you guys about maybe this one 5 minutes for you to do question 9. Then I'll go through question 9. Then we'll look a little bit about entropy before I move on to chem equilibrium. Remember, this is a question regarding experiment. So experiment always use 2 sets of formula. Okay, can I go through this one? Now, this one is a very straightforward question. It's actually an energetics question that involves experiments. So remember, the two formulas you need to use is Q equals to MC delta theta and then delta H. But the difficulty of this question is what is the divided by number of moles that I need to use? So I know some of you guys will find this a little bit hard because you didn't know what is CH3 and H2. But if you did organic chem, you would know that that was a weak base. It's an amine, okay? But now I'll let you guys know that this is actually a weak base. So first things first, they have two solutions, your methylamine as well as sulfuric acid, added together in a plastic container. Temperature rose is 6.3 degrees Celsius. So this is an exothermic reaction. Now, they said that the process is 90% efficient. So you do not take into account 100% of the heat at first. Understand? Okay. So calculate the standard enthalpy change of the reaction, which means my delta H, assuming that my C is 4.18 and my temperature change is 6.3 degrees Celsius. So I know Q equals to MC delta theta. However, this Q is what we call my apparent Q, meaning the apparent amount of energy that is required in the experiment, or the amount of energy that you used in the experiment. Now, M is the mass of the volume, the mass of the solution, which is equivalent to 55 cm cubed. Okay, how do I get 55? I added 30 with 25. Now, C is 4.18, delta theta is 6.3. So from here, my apparent amount of heat evolved will be equivalent to 1448.4 joules. Okay, however, this is only 90% efficient, meaning your energy absorbed by the substances inside your beaker or your flask or whatnot is only 1448. The actual heat that was released due to the experiment is equals to 1448.4 divided by 90 times 100%. So this should give you a value of 1609.3 joules. Understand? The next thing I want to calculate is therefore my delta H. However, I know that delta H of the reaction is equals to what? Equals to my Q. Now I know temperature rises, so it's exothermic, so negative sign, by the number of moles of water, since this is a neutralization process. The question is now, how do I find my number of moles of water? Okay, so that's when you need to write equation. First things first, I have my base here, CH3NH2, reacting with H2SO4. Okay, now what do they form? An acid is a substance that gives off H+. A base is therefore a substance that will receive H+. So therefore, my base here will form NH3+. End up, my SO4 will be formed, SO4 here. But since it's SO4 2-, that's when my salt form is CH3NH3 bracket 2SO4. Okay, so I balance my equation like that. But previously, you realize that my base here, CH3NH2, when dissolves in water, acts as a base by releasing CH3NH2 plus, NH3 plus, and OH minus. So if I have 2 moles of these that is reacting, I will have 2 moles of water that is reacting. Means the number of moles of CH3NH2 will give rise to the number of moles of H2O. Okay, so I repeat. Since this is the weak base, it dissolves in water partially to form OH minus. Then this is the salt that is formed, but the cation part of the salt. The cation part of the salt, maybe this one I change, okay, reacted with the anionic part of your sulfuric acid to form my salt here. So the ratio 2:1. Okay. Now, why do I need to write equations? Because you realize the question actually gave me information of 2 substances, my base as well as my acid. I will need to find out who is the limiting reagent. So as such, first things first, the number of moles of CH3NH2 equals to 30/100,000 times 1.0, 0.0300 moles. Whereas the number of moles of H2SO4 is 25/1000 times 1.0, 0.0250 mole. So end up, do you realize something? If this is 0.0250 and this is 0.0300, who is my limiting reagent? The base, correct? So therefore, your CH3NH2 is the limiting reagent. So using the mole ratio of these, you can then find the number of moles of water. How so? The number of moles of your base is the same number of moles as your water. So therefore, number of moles of water is also 0.0300. Understand? So bringing that back now to this will be negative 1609.3. I divide by 1000 to change it into kilojoules. Then divide by the number of water, moles of water. So end up, I will have negative 53.6 kilojoules per mole. You understand? Okay. So this is slightly a little bit extended into mole concept. That's why it's very confusing. Okay, because you need to find out the exact number of mole of water. But I can't do that without my limiting reagent. If the question only gave you information for one substance, then it's very straightforward. That would be the limiting reagent. But they didn't for this. Okay. Now, the next part, they said, predict if the enthalpy change of the reaction will be higher, the same, or lower if now my sulfuric acid is replaced by a weak acid. What happens when sulfuric acid is replaced by a weak acid? The enthalpy change value will become less exothermic. Okay, why? Because heat that is released is now taken back to further dissociate. So we say it becomes less exothermic. This is so as sum of the energy that is released is required to cause ionization of the undissociated weak acid molecules in order for neutralization to occur. Okay, Ken? Now, good. The next one, can we take a look at entropy now, once you guys are done? Entropy, I'll just very quickly go through because entropy is a very easy concept. Entropy is the concept of disorderliness. Generally, the more disordered your substance, the much more easily the entropy will increase. Okay, so there's no notes for these, but I've given you guys the worksheet for entropy. Okay, I just need you guys to write these down. Yeah. When we take a look at entropy, remember at the end of the day, we want to find delta G. I want my delta G to be negative so that the reaction is spontaneous. Okay, there's no notes. You can just write it down under your summary or whatnot. But what exactly is entropy? I need you guys to understand that entropy is the degree of disorderliness. Meaning to say, the more chaotic your system is, the more disordered the system is, the higher your entropy. So changes that causes a system to become more random, we say entropy increase. Example, I increase the number of moles of gas molecule. When I add more molecules in, I become more disordered. Correct? Number two, I change from solid to liquid to gaseous state. The more I change it into the gaseous state, the more random they become. So therefore, my entropy increase. However, most of the time in explanation for question, they will ask you to explain why entropy increase. That's where the way you answer will be something like that. You say, for example, the number of moles of gaseous molecule increases. Hence, there is an increase in the degree of disorderliness. As such, the number of ways to distribute energy increases, and therefore entropy increase. So don't straight away skip these two steps and jump from here to here. They will not give you the mark if you don't explain to them. The reason why entropy increases is mainly because now my particles has more way to distribute energy. So they are more disordered, more random. You understand? Okay, so anything, if you think about it, just try to read the question and see, does this increase my disorderliness? If it does, my entropy increase. As of now, they do not require you to calculate entropy. So you just got to learn how to explain. Now, overall, entropy. Enthalpy, yes. Entropy, not so much, except for the final minus initial. That one is very straightforward. Just calculate entropy change. But there's a formula to calculate entropy, but it's not needed inside our syllabus for now. Okay? Okay, but at the end of the day, we want to find out what is delta G, whether it's spontaneous or not. Whether a reaction is spontaneous or not is dependent on whether your delta G is less than 0. So if you take a look at the equation, what does that mean? That means I want something to be as positive as possible for my entropy. Because if this is positive, no matter what temperature it is, my base value here will always be negative. In addition, I want something that is very negative in terms of enthalpy, means I would prefer exothermic reaction. So negative and negative add up together will give you a delta G that is very negative. Understand? Okay, so that is basically what entropy is about. Clear? Can? Okay, good. So that is that. Now the answers I will upload onto the G drive. You guys try the questions, then you guys can just download the answer key and just look at it. Okay? Okay, so I won't go through much of this one here because we don't have a lot of time. But can we move on to the next part of your summary? We're going to look at chem equilibrium. Okay, now chem equilibrium, this topic, just a show of hands, any of you guys have already done chem equilibrium in school? Almost everyone. How was this? Easy? No, not easy. What was the main thing that you guys cannot understand for chem equilibrium? How to use the IC table, or when to use the IC table? Is it? And Le Chatelier's? Okay, now first things first, let's take a look at chem equilibrium. I need you guys to understand that chem equilibrium only exists because of reversible equation. When you learn the next few chapters, acid-base equilibrium, solubility product, all of these includes reversible equation. And reversible equation does not just means that you have a double arrow. It actually meant that there is a forward reaction and a backward reaction taking place at the same time. And because of that forward and backward taking place, we reach a state of what we call dynamic equilibrium. Okay, so the main thing about this topic is us trying to find out at this dynamic equilibrium period, what exactly is the concentration of my reactants? What exactly is the concentration of my products? Understand? So in order for you to do chem equilibrium topic, you need to first understand that your reaction has reached a state of dynamic equilibrium. Now, for those who still don't know what dynamic equilibrium is, let me just maybe show you guys a very, very short video. This. Okay, if you guys can already see, the one on the right hand side, the one with the greater number of heats is the forward reaction. Then can you see the left side is trying to do a backward reaction? Okay, so this is where the reaction just starts. Now, when you realize that the reaction is complete, the forward reaction is taking place, the backward reaction is taking place, right? But the concentration of the reactant and product, do they change? No, the backward one, the forward reaction, the left right hand side, the concentration remains the same. The left hand side, the concentration still remains the same. Can you see that? They are not necessarily the same, but they don't change. So this is what we call reduced. Understand? Your job in doing KC is to find out how much of the forward, how much of the reactant, how much of the product is at this equilibrium state. You understand? Okay, so this is what we call dynamic equilibrium. Because a lot of students tend to have the misconception that equilibrium means no more reaction taking place already. Everything is like stopped. But no, the forward still takes place, the backward still takes place. So at the dynamic equilibrium scenario, how do we then find a value? That's where we find what we call our Kc. But Kc did not start off as Kc. Kc was actually what we call a reaction quotient. But the only thing is we attributed it to Kc because it has reached a state of dynamic equilibrium. And Kc, I need you guys to always remember, is the ratio of the product over the ratio of the reactants. Okay, remember Kc, like Kp, is ratio of product over reactants. Then it becomes pretty much like a math game. If my Kc is greater than 1, what does that mean? Means my product is more than my reactants. So the forward reaction was favored. If my Kc is less than 1, that means my backward reaction is favored. My reactants became more than my product. Understand? Okay, but always remember Kc, Kp is all product over reactants. Now, for Kc wise, we actually use concentration at equilibrium. For Kp, we use concentration at partial pressure at equilibrium. Understand? The next thing you take note about Kc and Kp is they are all fixed at fixed temperature. So that's the most important because the questions like to trick you by asking you what is the change in Kc. You must check if the temperature did not change, my Kc don't change. You understand? Okay. So at the end of the day, what do they want you to do? They want you to write down a Kc value. They want you to find the Kc value by substituting in concentrations. In order to find the concentrations or even the partial pressure, that's where they will do the ICE paper. Understand? Okay, so that is pretty much for KC. But one thing I want to talk about is this one here. Now, for KC, much more for KC and not so much for KP, is that when we look at equilibrium constant, we're actually looking at concentration of a substance. But do we include the concentration of solids? No. What about for liquids? No, only if the liquid is used as a solvent. Meaning to say, if you read the question and the question said that the substance was dissolved in a solvent, we don't include that into KC. However, if your liquid was produced as a product, like water came out as a product, you have to include the concentration into KC because there was a major change in concentration. Understand? Okay? Only when it's a solvent, then you don't include it into the KC. Clear? Okay, good. So can we just take a look at a very quick question for chem equilibrium? Just let you guys try one question. Question 4 for this question here. Page 2, question 4. Give you guys about 5 minutes to try this question, then I'll go through. Okay, now let's go through this one. This question is still okay, just that it involves a little bit of ideal guesses. But basically, they gave you a reversible equation. So that means you can calculate Kc, or in this case here, Kp. Then, can you read the question carefully? They already gave you the equilibrium partial pressure at 27 degrees Celsius. So you do not need to do an IC table for this case here. Understand? Then they said, given that the total pressure is equal to this, calculate the Kp for this equilibrium. Now, most of you guys would have already known Kp is equivalent to product over reactant. So product of SO3, partial pressure of SO3 squared over partial pressure of SO2 squared times partial pressure of O2. I have the partial pressure of SO2. I have the partial pressure of SO3. Whose partial pressure am I lacking? Oxygen gas. Now, how do I find the pressure of O2? Do you realize they gave you the total pressure, 110? So partial pressure of O2 is equivalent to the total pressure minus the partial pressure of everyone. Understand? So think of partial pressure as like space that is being occupied inside a volume. The individual spaces add up together to give you the total volume. Understand? So from here, all you got to do is just put in the values. You will have 35 square over 32 square times 43. And then this will be equivalent to 2.78 times 10 to the power -5 per Pascal. Make sure you write your units correctly. Yeah? The correctness of the unit determines the correctness of the answer. Understand? Then now for part 2, it says calculate the total volume occupied by the equivalent mixture if I have 20.5 mole per dm cube of sulfur dioxide present at equilibrium. Now, in order for me to find the total volume, what we're going to use, given the number of moles and given the pressure, if you guys can remember, is your ideal gas equation, PV equals to nRT. So to find V, what do I need? I'll need nRT over P. However, if my number of moles you used were to be 20.5 for the number of moles of SO2, then 8.31 and a temperature of 27 plus 273, because the question said 27 degrees, then the volume, sorry, the partial pressure that I use would have to be for SO2. So 32 times 10 to the power 3. So the number of mole corresponds to the partial pressure, and hence the total volume is equivalent to be 1.60. If you ask, can I use total pressure at 10? Yes, you can. You have to make sure you find the total number of moles for SO2, SO3, and O2 in that case at equilibrium. Okay? Why? You have managed to get this? Okay, now the next one, number 3. Predict and explain how position of equilibrium changes if you were to add in catalyst. Now, I need you guys to take note. What does catalyst do to a chemical reaction? Increases the rate. But for a reversible reaction, it increases the forward and the backward to the same extent. So what happens to the position of equilibrium? There's no change because now it affects both the forward and the backward reaction. You understand? So for part 3, they ask you, how does the position of equilibrium changes? You said that first things first, they want you to explain. So you got to say the catalyst increases the rate of the forward and the backward reaction. Don't just stop here, by the same extent. Okay? Hence, allowing the position, the equilibrium position, to be reached faster, but there will not be any change in the equilibrium position. Okay, so according to Le Chatelier's, catalyst doesn't really change the position of equilibrium much. Okay, now lastly, here you realize they changed the temperature at 40 degrees Celsius. The chemist continued his investigation on a new mixture by monitoring the changes in partial pressure of the individual gases. After the system has reached equilibrium, he compressed the volume. Okay, then sketch on a graph how compressing the volume changes the partial pressure. So first things first, what does compressing the volume do to the reaction? It increases the what? If you realize these are all gases, and I compress the volume, what happens to the reactants and the products? It increases the pressure. So for all of them, the pressure at T increases. Understand? However, when you draw this type of graph, I need you guys to pay attention to the number of moles. If the mole ratio is 2:1:2, the way you extend must also be proportional. 2x, x, 2x. Understand? Okay. Next thing, according to Le Chatelier's, what happens when I increase my partial pressure? Or what happens when I increase my pressure? According to Le Chatelier's, my system will want to favor the reaction that produces lesser number of moles to decrease it, correct? So is it the backward or the forward reaction? The forward, because this is 2 moles, whereas the backward one is 3 moles. So end up you have more product. More product means reflective on the graph. My graph for product increased by 2y. Okay, which means my reactants should decrease. but proportionately, my reactants decrease by Y, and the other side decrease by 2Y. Understand? So you need to make sure that these are drawn correctly, but Y must be less than X because it's a reversible reaction. Not all of your reactant turn to become product. Do you understand? Okay. Okay, so obviously I can't go through all of it because one session I can't go through anything. I'm not a miracle worker, but hopefully you guys at least understand something today, and hopefully you guys can apply it in your question. The key thing is always remember, understand before you memorize. Once you understand, you can then do things much easier. Understand? And when your teacher say read the question, literally everything inside the question read. It's like, you know, make markings, highlight, do a lot of inkling to lead yourself to the topic that you remember or the topic that you memorize and get out from you. Understand? Okay. Okay. So hopefully you guys can benefit from today's session. Before you leave, this one they will put it up inside the Telegram, Instagram, social media. You can just take a look